Okay, let's continue our discussion in section 1.10, where we have some look back at limits and some additional theorems that we had, uh, including these two. So the limit as t approaches 0 of sine t over t is 1, and the limit as t approaches 0 of 1 minus cosine tl over t equals 0. So these are proven facts. Both of these, if we would plug in limit of the quotient as a quotient of the limit, would be 0 over 0 forms. And so what we're going to do is we're going to utilize these to manipulate things in a way that we could leverage or utilize these proven facts. So let's look at some examples on this, shall we? We did some here with in class today on the limit as t approaches 0 of sine t over t, and looked at how to manipulate and make some things look like that. So let's focus on this second theorem that we have here and see if we can come up with some examples here. So initially, I'm going to do a few that maybe are in the book here. So let's look at one that might match that. I'm going to look at number 11 first of all. So number 11, this is on page 101, so it's nice to be in triple digits on the pages. So anyway, but this one says the limit as x approaches 0 of 1 minus cosine 4x all over x. Okay, so one thing that we notice is that if x approaches 0, then we also have that 4x would approach 0. So I can kind of ignore that and utilize this. So 4x would be like my t in the theorem version. So what I really want to do is I want to make the denominator look that like 4x as well. So to do that, I'm going to multiply by 4. But of course, what we have here is then, since we divided by 4, I would have to multiply by 4 as well. Okay, so if I do that, that's a manipulation that I can use. Now I've got 4x in the denominator, so I could replace that with t or z or whatever, or a. So now it's the limit as a approaches 0 of 1 minus cosine a over a, and so we can utilize that theorem. But also, I can, to solve this, I can pull that constant here out in front, and so this is going to be equivalent to 4 times the limit, in this case, as 4x approaches 0 of 1 minus cosine 4x all over 4x. And of course, since this is the same thing here, here, and here, I can use the theorem and say that this is just 4 times 0, right? So that limit was 0. So then my final answer then should be 0. So anytime I'm doing some of these odds, go ahead and pause and try it on your own, and then resume to make sure that you can get some things of this nature. But I assume that you would have already done this one. And of course, it's equivalent to this because limit of a constant times a function is the constant times the limit of the function, which is why we can pull that 4 out front. So there's number 11. So let's try a little more complicated one, number 13. And once again, I would prefer that you try this first just to see what you did. I actually did try this on an earlier version that I was trying to record when I had some technical difficulties. And there's a couple of different approaches here that we could try and take. But ultimately, what we're looking at on number 13 is a limit as x approaches 0 of 3x squared over 1 minus cosine squared of 1/2 x. Yeah, 1/2 x there. So that would, we don't really need those parentheses, but this is what it would look like. And so there's a couple of different approaches. Once again, I'd like you to try this on your own and see if you can make it look like it. So go ahead and hit the pause button, try something. When you come back, if you get stumped like I did initially, I'm going to show you how one thing that I did. Of course, this is kind of a flip or reciprocal of what we might think that we have. But what I may do initially, you might say, hey, if I plug in 0, what do I get? On the top, I'm going to get 0, so that's 0. And on the bottom, I would also get 1/2 of 0 is still 0. Cosine of 0 is 0. Square it. You would get, excuse me, cosine of 0 is 1, and then squaring that is 1, and then 1 minus 1 is 0. So long story short, this is a 0 over 0 form. So what you might do is say, hey, you know what? I think I can manipulate this by factoring, and you write it as 3x squared, and this is the difference of two squares on the bottom. So you might say, hey, this is 1 plus cosine half x times half x times 1 minus cosine half x. And so you might do that, and then you say, hey, I'm going to split this up, and then I'm going to take that 3 out front, and then times the limit of the product. What I could do is limit as x approaches 0. I can put that limit of the product as product limit. I could put x over 1 plus cosine half x times limit as x approaches 0 of x over 1 minus cosine half x. And so you might try something like this, and then if you did that, you can say, hey, limit of the quotient is a quotient limit. So this is 3 times, I'm going to use a different color here for this one. Let's just look at this one. And if I plugged in 0, I get 0 on top, but what do I get on the bottom? The cosine of 1/2 times 0 is cosine of 0 is 1. 1 plus 1 is 1. So that's 0 over 2, which actually equals 0. So this part here equals 0. So you might say, hey, I can go ahead and stop. And my limit is 3 times 0 times whatever the last one is. And so maybe you're thinking that the answer is 0. Of course, if you flip in the back of the book, you're going to find out that that is not the answer that they have. And then you're going to get frustrated and wonder why not. So the focus is what is in the box. So that's the question mark of the day. What about this one? And why is it a problem? Well, if I've got this, I could look at the reciprocal. I'm going to see if I can just erase some stuff up above so that you can still see the green there. So it looks, I don't have a big enough eraser, it looks like. But anyway, I'm going to come back and I'm going to use green over here. So I think you've got a pretty good board over here for number 13. So let me go back and get my green again. So what I'm going to do is I'm going to look at the reciprocal of that. So this would be the limit. So once again, I'm just focusing on the green box here. The limit as x approaches 0. The reciprocal of this would be 1 over the reciprocal of that, right? So instead of a over b, I can write it as 1 over b over a. So in the bottom, I could have 1 minus cosine of 1/2 x over x, and the denominator looks more like my theorem of what I had. And of course, it would look exactly like my theorem if I go ahead, and I'll use some purple here, but if I make that 1/2 x and make that a half here, I can do that as long as I multiply the denominator by 1/2 as well. So now I've got basically like my t there, and I can do this. And so really, if I do this, of course, what is that limit? So limit, by the way, this I can put on top if I can get back to my writing, and not that one, sorry, I didn't mean to cross through that one. Instead of dividing by half, I can multiply by 2 on top, and then on the bottom, I can use the limit theorem here, and of course that is 0. So what ends up being in the box down here, let me go back to green, is actually times 2 over 0, which really that's going to blow up, right, to positive or negative infinity. So the question is, hey, if I've got something approaching infinity and I've got something approaching 0, which one wins? Well, as we've noticed in the past, sometimes the infinity wins, sometimes 0 wins, and sometimes it's a proportionate approach, and it ends up being a fixed number. So this is really indeterminate. So long story short, as much as we would have loved to solve it by factoring, that doesn't work out for us at all in this problem. So let me go back and let's revisit what we could possibly do to solve this problem. So once again, it was the limit as x approaches 0. This is number 13 of 3x squared over 1 minus cosine squared of something, 1/2 x. Okay, but the reality is, if I look at the denominator and say, hey, what's that like? Well, if I remember that sine squared plus sine squared z, I'll just say z plus cosine squared z is 1. That is an identity that we have from trig, right? So really, and of course, sine squared z is 1 minus cosine squared z, right? So in this case, here's my z. My z is 1/2 x. So I can rewrite this as 3x squared over sine squared of 1/2 x. So I could rewrite this whole thing like this using my trig identity. And then now I can use the first theorem that we went over to try and come up with this. And of course, that's the reciprocal of our actual theorem. So what I can do then, I'm going to clear my screen. And I'm going to say, hey, this is the equivalent then to the limit as x approaches 0 of 1 over the reciprocal. Okay, the reciprocal would be sine squared 1/2 x, and then of course, and then it was what did we have? We had 3x squared on the bottom, so or that was on top. So the 3 was still on top, but I'm going to take the reciprocal here. So anyway, so it's 1 over the reciprocal. So I got the 3x squared there as well. And then what can I do? Well, so that 3 is really like times 1/3, right? And times 1/3 on the bottom is like times 3 on top. So I can just put that 3 on top. And then now I've got something that's starting to look close. But once again, I need my 1/2 x is my term. So let me change the color here. So I've got 1/2 x here, and of course, as x goes to 0, 1/2 x also goes to 0. So instead of x squared, I could put 1/2 x quantity squared, okay, there, because I have a squared here too. And of course, that's dividing by a fourth. So I got to multiply times a fourth, right, to undo that. And then I've got my 1/2 x, my 1/2 x, and my 1/2 x, and can use the theorem. So once again, instead of dividing by 1/4, I can multiply by 4. So I end up getting 12 on top. So that's equivalent to the limit as 1/2 x goes to 0 of 12 over this. And what I can do is say, hey, that's sine of 1/2 x over x quantity squared, over 1/2 x quantity squared, right? So I can rewrite it like that. And of course, now I can use the theorem on the bottom. So by the theorem, this is 12 over 1 by my theorem squared. Of course, 1 squared is 1. So this ends up equaling 12 for my final answer. So number 13 actually does have a correct answer in the back of the book of 12, as long as that's what your book has. So a little bit awkward for sure on trying to come up with how in the world did that equal 12. So we had to manipulate that the right way. So let's look at just a couple of other ones where we have to maybe use both theorems. So once again, try these on your own. So let's go ahead and try 17 on your own. Pause the screen when we get going here, see if you can come up with an approach on this one. But now we've got the limit as x approaches 0 of 1 minus cosine 2x all over sine of 3x. Okay, and what I'm going to do is I'm going to leave some room here, because what I kind of want to do is make both of these look like our theorem that we have. So on top, if I've got 1 minus cosine of t, I'd want over t, so that's over 2x. So I have that. So of course, as x goes to 0, 2x goes to 0 as well on the top. But if I am dividing by 2x, I also have to multiply by 2x, right? But now I have something that looks like my theorem on the top. And of course, on the bottom, let me use red here. I've got sine of 3x, but I could have sine of 3x over 3x if I do that. And of course, as x approaches 0, 3x approaches 0. I would have something that looks like my theorem, but I divided by 3x there, so I'd also have to multiply that by 3x, right? And then once again, now I can say, hey, 2x over 3x, those x's cancel out because x doesn't actually hit 0. And I've got a 2/3 that I can pull out front because the limit of a constant times a function. And then times, and then I could use my theorems here. So limit of a constant times a function is the constant times the limit of the function. The limit of the quotient is the quotient limit. Of course, on top in green, and I'll go ahead and put it in green, that theorem using the limit as 2x approaches 0 of this green box is actually 0, right? Whoops, and then divided by, sorry, I didn't want that dot there. Let's see if I can erase it. So 0 is in the green box, and on top, and then divided by, let's put in red what the denominator is. By that theorem, that's divided by 1. And so basically, this ends up being 2/3 times 0, which ends up being 0. So the answer in the back of the book, I didn't verify, but it should be 0 if the book is going to try and be correct. So I'm going to do one more like this, and then cover the squeeze theorem in a separate recording. So right now I'm having good luck with the board letting me write. So I'm going to keep rolling with it. Let's look at number 15. So number 15, once again, want you to try these on your own before you continue watching the video, because everything's easy if I'm doing it, but we want you to be able to do it. So now I've got limit as x approaches 0 of tangent x over 2x. Okay, well in this case, it's a little bit ugly on my tangent there, but anyway, how's that? So this doesn't look like either one of the theorems that I had. So what I really prefer to do is rewrite tangent differently. And so let's rewrite tangent as sine of x divided by cosine of x. And of course, dividing by cosine of x, I can multiply by 1 over cosine x. So really the cosine x could be in the denominator, right? So this is equivalent to the limit as x approaches 0 of sine x over 2x times 1 over cosine x. Okay, so in this case, now I can say, hey, that kind of looks like my theorem. So in fact, if I just think, be careful, you can't multiply the top, you can't put a 2 inside of that sine x because that's not multiplying by 2. It's taking the sine of 2x is not the same as 2 times the sine of x. So really, we already have the limit as x approaches 0. Of course, what could I do with that 2 in the denominator? I could just pull it out front because that's a constant, right? And so what I'm going to have is 1/2 limit as x approaches 0 of sine x over x is 1. So that's what would be in the box from the theorem. And then times, and I'll go ahead and use a different color here. The limit of this one, so limit of the product is product of the limit, I can go ahead and say limit of the quotient is the quotient limit, and on top we have a constant, we have 1, and as x approaches 0, what does cosine x approach? Well, that approaches 1 because the cosine of 0 is 1. So what I end up having here is 1/2 times 1, and of course, so I get 1 in the box there. But anyway, what does this equal for a final answer? For a final answer, this equals 1/2. So we utilized the first theorem that we had, the limit as x approaches 0 of sine x over x is 1, okay? And we're able to rewrite this using the definition of tangent to figure out that the limit as x approaches 0 of tangent x over 2x exists and equals 1/2. So hopefully that's some good examples for you on utilizing those first two theorems that we went over that involve 0 over 0 forms with sine and cosine, and leveraging those theorems to come up with some other things. So once again, and I'll do a separate recording of the squeeze theorem.